Bismillahirrahmanirrahim. Assalamualaikum to panel. I am Safwan and Dr. Awang. My name is Samir Shamil bin Safwan Stephen. My ID number is AA17066 and my supervisor is Dr. Sharifah Mazura binti Said Moses. So the title of my thesis is the potential of oleochemical waste to serve as a partial cement replacement in concrete. So for the presentation outline, include the introduction, problem statement, objective, scope of study, significance of study, literature review, methodology, result and discussion, conclusion, recommendation, and lastly is references. So for the introduction, the cement is one of the important components in mixing concrete, but the production of cement has recognized as the world leading source of greenhouse gas (GHG) emission. Therefore, the various solution method were carried out to reduce the GHG emission. Next is Malaysia has become a great consumer essential of oleochemical, using a large supply of the indigenous raw materials such as palm oil, palm kernel oil, and even coconut oil, which is almost 70% of the global oleochemical production capacity. Moving to the next slide, which is content about a problem statement. So the problem statement first is the cement manufacturing industry is currently under close scrutiny due to the huge quantity of carbon dioxide (CO2) produced. So the production of cement needs to be reduced to avoid the negative impact to the environment. Also, with the oleochemical causing a serious environmental problem. Oleochemical not to be environmental safe, but the industrial process wastewater from this industry which contain fatty acid, glycerin, organic residue, inorganic acid that really need to be handled before being discharged to the atmosphere, especially in any water resource. So next part is about my objective, which is I got a 3 M about the research, which is first is to investigate the effect of oleochemical waste as a partial cement replacement on the corrosive strength of concrete at edge 7 and 20 day. For the next objective is about the flexural strength test of concrete at edge 7 and 20 day. And lastly is to determine the water oxidation of concrete containing oleochemical waste as partial cement replacement in concrete at edge 20 day. So next, talk about the scope of work, which is involved. The testing is conducted in the concrete lab at UMP Gambang. So the oleochemical waste obtained from FAG Oleochemicals Sdn Bhd located at Gambang, and the percentage of oleochemical used as a partial cement replacement, which is 0 as a plain concrete or controlled concrete, and the minimum is 5% and the maximum is 20%, and other is 10% and 50%. So the specimen form is a cube. The specimen form in cube and prism concrete. So the total specimen, which is 70 and 45 cubes and 30 prism. The sample of the comprehensive and fragile test we tested at age 7 and 20 SD, while the sample for authorization only be tested at the age of 20 SD. So the significance of this study is the research can reduce the depositing oleochemical sludge waste by replacing the partial quantity of cement. Besides, it's able to reduce the amount of waste ending up at the landfill. And production of cement also can cause an emission of greenhouse gas used by reducing the production of greenhouse gas. Effect also reduce. So this is the literature review that involved in my thesis. So I put a little on the slide. Okay, moving to the methodology, which is the preparation of raw material, which is have cement, water, sand, oleochemical waste, and cost aggregate. For the mixed proportion, which is the replacement if 0, 5, 10 and 50 and 20% of oleochemical waste, the replacement is by volume. And the sample preparation, which is first step in mixing of the concrete, casting of the concrete, and curing the concrete by using water curing method. And the testing involved is corrosive strength test, fragile test. Lastly is water oxidation test. So how do I do with the oleochemical waste preparation? First, picture show the oleochemical waste before grind. It is the originally physical from the factory for the first picture, and the second picture show that the grinding machine that I use for grind the oleochemical to become ash, and the third picture show the result of oleochemical waste ash after grind. So for the concrete mix design, the concrete grade is targeted for 25 MPa, and the mix design was calculated using the CMD, concrete mix design form, and there is sample. The table shows the sample of concrete mix design in my study. So moving to the concrete preparation, first step is find and coarse aggregate wood mixer in a drum mixer. Next, the OPC cement, ordinary Portland cement, with oleochemical waste are added to the drum mixer, and then water was added, and lastly the mixture was ready to fill into the mold. So here is some of list of experiment, which is first is slump test to determine the effect of oleochemical waste as a partial cement displacement on workability of concrete. Next, moving to the compressive strength test, which is to investigate the effect of oleochemical waste as partial cement displacement on compressive strength of concrete. Lastly, about the fractional strength test, which is to determine the fractional strength of hardened concrete specimen by using a simple beam or prism with reference to the standard strip standardization third point method. For the result and discussion, which is involve slump test, compressive strength test, fractional strength test, and water absorption. For the slump test, the slump reading decrease as increase the percentage of oleochemical waste. The decreasing in slump test reading is influenced by the particle size of oleochemical, which causes more water needed. Should be the data include 5%, 50%, and 20%, but due to the constraint of COVID-19 epidemic, the only available data is the trial and error mix design, which is 10% of oleochemical waste displacement and 0% which is for the control. Same with the compressive and fractional, the only available data is control, which is 0%, and trial and mix design 10%. So for the compressive strength, at the 7 days, show that the control is 22.08 MPa, and for the 20th day is 29.4 MPa, while for the 10% is 0 for both. This is because the increase of 10% displacement of oleochemical waste result loss of the compressive strength of the concrete. Try and error mix design did not show a good result because oleochemical did not act as a filler to fill up the existing void, which met the internal structure of the concrete less packed. Based on the result, show that there are no positive reaction during the hardening of concrete due to inactive pozzolanic ash of the oleochemical waste. So for the fractional strength test, for the 7 day is 5.73 MPa, and for the 20th day is 6.78 MPa. For the 10% is 0 for both. By increasing the 10% replacement of oleochemical waste, the result of fractional strength of concrete is 0 MPa. The presence of oleochemical sludge waste failed to contribute the chemical reaction with the calcium hydroxide, which should provide more secondary CH gel during the hydration process in strength development. Those failed to improve the concrete strength. Moving to the water absorption, as I stated before, the limitation to enter the lab during the movement control order 3.0 causes the lab work undone. So this picture shows how the brittle the concrete is for the trial and error mix design for 10% replacement. So first picture shows the concrete cube failed during the removing from the mold. Next picture shows the concrete cube after the compressive test. It look massive, and last picture shows the concrete prism failed during removing from the mold prism. Lastly, about the conclusion, since the try and error, which is 10% replacement, makes design fail, the objective cannot be achieved. So the compressive and flexible strength of 5, 15 and 20% cannot be obtained due to the failure and trial and error mixed design. Because the trial and error mixed design fail, I cannot continue on 5, 15 and 20%. And also the limitation to enter the lab during movement control order causes the lab work undone. So the recommendation for the feature study, first is reducing the particle size of oleochemical waste ash by grinding more. So to increase the reactivity of pozzolanic reaction and allow the oleochemical waste ash to fill the void in concrete, those to make the concrete more denser and increase in strength. Second is the process of preparation oleochemical during controlled combustion from factory should be taken into account to make sure the oleochemical waste could highly produce pozzolanic ash or become more reactive during the pozzolanic reaction. So here's some my differences, and that's all from me. Thank you.